It gives me immense pleasure to welcome you all to the launch and orientation session of the Deep Tech Hackathon 2026. Today's event brings together students, faculty, and industry leaders all united by one common goal. To build India's next generation of semiconductor innovators, this hackathon is a national level initiative led by IESA, India Electronics and Semiconductor Association, with NXP Semiconductors as the official hackathon sponsor and Inter-Institutional Inclusive Innovation Center I4C as the official hackathon implementation partner. Before we move forward, let's pause and reflect India today. India today stands at a critical inflection point. Semiconductors, electronic systems, system designs, AI-enabled chip design, and embedded intelligence are no longer niche domains, they are strategic national priorities. And innovation in these areas cannot remain confined to labs, textbooks, or conferences. It must reach classrooms, campuses, earlier career innovators, and young engineers across the country. So this is exactly what this hackathon is designed to do. So to formally begin today's session, it's my pleasure to invite and formally open today's session. I invite Mr. Vishwanathan KG, Director, Workforce Development, IESA. Having 30 years of experience in education industry, his expertise also lies in strategic partnerships, relationship management, sales and marketing, startup venture capital, and more. Sir, over to you for the welcome note and opening remarks.
Absolutely. Thank you so much. Thank you so much. So I would like to first of all welcome all the participants who have joined us on time, and we are happy to have this is first of its kind. As IESA, we are doing this hackathon in the first time in a program called Vision Summit. As IESA, I just wanted to take a couple of minutes. IESA is for no for India Electronic and Semiconductor Association. It is an association which has got around 450 plus electrical electronics manufacturing companies, supply chain companies, and we operate as a premium industrial body. And when we thought about this hackathon, when we know we had multiple ideas. In fact, we wanted this hackathon to be a bridging between academia as well as the industry, right? Then we had, in fact, a fantastic conversation with multiple people, and we drilled down to around 50 hackathon statements, problem statements. In from there, we came down to 10, and then we shared the 10 to the industry people, out of which now there is a problem statement which has been refined by our hackathon sponsor, industry sponsor called NXP Semiconductors. I'm sure each one of you know the contributions that NXP is doing in the semiconductor domain and in the industry. I would like to welcome senior manager, senior management person who's representing NXP, Mr. Hitesh Garg, Vice President and India Country Manager, and also Dr. Mallikarjun, who's a Director Technical from NXP. And also would like to welcome senior level leaders, Dr. Vivek, who's a CEO of I4C, and Shaurabh, who's the Program Manager who takes care of this implementation. I4C has got around 10 plus years of experience in terms of doing hackathon as a service, and they are regularly doing what do you say, national and international hackathons with their practices and regular systematic approach. I'm sure each and every student will find it easy for us to navigate this hackathon till the end. And last but not the least, I would like to welcome Mr. Ashok Chandak, who is the president of IESA, and he under his leadership, we as IESA team, no, we have two different teams. One is an executive council member team, which manages the entire no operations, and President Ashok Chandak handles the operation entire India business, as well as he is also a president for SEMI India. And we have a team of people, secretariats who operate in IESA, right? More than that, I would like to welcome all the deans, academicians, and professors who have joined us for this inaugural session. And students, or the, I would say, superheroes for this particular hackathon. I would like to welcome. We have already seen 303 registrations from last 48 hours. So I'm sure this is going to be a very big event for all the students. They will have a fantastic experience working with industry leaders like no NXP team, and also hands-on sessions, and also mentorship sessions. And last but not the least, you're going to have a top 10 team presenting their ideas and solutions in a vision summit on 26th February 2026. So now I would like to welcome Mr. Ashok Chandak, President, to give us a note. Thank you.
Hi,
Thank
good
you,
afternoon,
Mr.
everyone. Can somebody tell me if I'm audible?
Yes, you are, sir. Just give
Yes,
a
you are.
time, just give 30 seconds for her to introduce her.
Yeah, yeah. Okay. All right.
Please proceed.
Thank you, Mr. Vishwanathan. To now take this conversation deeper into why this hackathon matters at this point in India's journey. So, we are privileged to have with us a leader who has played a pivotal role in shaping the semiconductor narrative in India, who has 30 plus years of experience in semiconductor electronic industries and startup incubators, and he has successful track record of working leading across functional terms across worldwide geographies. It is my honor, sir, to invite you, Mr. Ashok Chandak, CEO and President. He will speak about IESA's vision, India semiconductor and landscape, ESDM landscape, and why this hackathon is critical step right now. Sir, the stage is all yours.
Very good afternoon, everyone. And my apology first that I'm at the airport in the launch, so a bit noisy in the background. I found a quieter place though, so I think should be okay. So first of all, thank you very much for everybody to join on this call, and also the strong interest which we have seen for this topic, as well as the hackathon and this particular technology sector. Uh, Something is big that is shaping up in India. The big conversations and the bold collaborations. Today, we see a very sharper, more confident vision for India's electronics and semiconductor industry. Last year, that is 25, would be remembered as a year of when India's electronic semiconductor story became real. This is where we moved from intent to execution, from MOUs to the concrete on ground, and from announcement to assets, aspirations to the credibility. The biggest win has been the trust which India has gained not only in India but also globally. And now we are seen as a serious investable destination in the field of semiconductors. With the multiple OSATs, ATMPs, that is assembly test, marking packaging, the design-led projects, the fabs, those are already crossed the approvals and these are in the execution phase under the India Semiconductor Mission. Overall, India sharpened its focus both in packaging as well as in the manufacturing, leveraging upon and the foundation of a chip design. Even the recently announced ECMS, Electronic Component Manufacturing Scheme, was highly successful with hundreds of approval project applications coming in and 46 were already approved. And this will become a game changer in India's electronics value addition locally. Semiconductor is going to play one important part in that. The India's chip design ecosystem is also accelerating with the startups, the MSMEs, with the global capability centers, the product creation companies, the IP owning and other things. Our partnership globally with the international organizations from multiple countries, be it Japan, the US, the UK, Netherlands, the Germany, Singapore, Malaysia, has also progressed a lot. And now we are in the phase called scaling up of the manufacturing. India has only one plant, that is a Semiconductor Complex Limited, called Semiconductor Lab now, situated in Mohali, Chandigarh. and now more plants are coming up. And to scale up and support this manufacturing facility, what we need is something different. And what you can do is you can always buy technology and buy the fab equipment to set up fabs, but the skilled manpower remains one of the big bottlenecks. And this is where all of you guys are going to come in play and add value, as when you start to work on the multitude of problems and multitude of situations, those are going to be unfolded in the manufacturing sector. There is a major opportunity available for all of you to make the difference. And India's manufacturing journey, which is started now, is, I would call, very much dependent on the skilled manpower and the skilled people and talented people like you. So those are going to solve the problems of tomorrow. And the hackathon plays an important role in that. As Vishwa mentioned, we had multiple themes, those were shortlisted. This one particular of analyzing the defects onto the wafers has been shortlisted and chosen. It may look like to be tough because many of you might not have seen the wafer, how it looks like and what is it. And then on the defects on the wafers, how they would be, what is the implication. But at the same time, it is also opportunity for all of you. Those are going to participate in the hackathon to really do a deeper study, go to the fundamentals, look into the root cause, and that way also gain knowledge and gain the expertise. Because whatever you do during this hackathon from the manufacturing sector perspective is going to be highly important and highly instrumental. And maybe some of you might also make your career into this particular field, which is showing promising. We are expecting India's electronics journey to go to $400 billion by 2030. At the same time, India's semiconductor demand is going to be $103 billion. And that means you see there is a huge scope of opportunities, those are unfolding. And that's where the manpower and the skilled people, talented people would be required. And all of you guys can play an important role. And keep in mind, and I always keep saying this, India's semiconductor journey is not a technology race. It's a nation building exercise. Many people keep asking that we were late and we have been late. We are not doing 2 nanometer, 3 nanometer. Just ignore these unnecessary comments and gossips, I would call. Because we are not in a technology race, we are building the nation. And you will not build the technology, you will not win the race by just jumping into 2 or 3 nanometer today, but for tomorrow. And to reach that level tomorrow, today we need to build our 28 to 180 nanometer kind of plants. And this is where this wafer related topic and the defect analysis, building that expertise and competence is going to be very handy and very useful. And that is how this team is going to be very instrumental. With that, I would say that I wish you all the best for this event. And we will welcome you at the Vision Summit, which is happening on 25th and 26th of February in Bangalore, one of the India's most premier and most sought after event for a technology sector, clearly focused on semiconductor and electronics. And our theme is simple: making India a product nation, making India a production nation, and making India a skill nation. And all of you are going to have a very important role to play in that. With that, I complete my opening speech, and I wish you all the best for participation in this hackathon and learn as you go along. Thank you.
Thank you, Mr. Chandak. One of the most exciting aspects of this hackathon is that it doesn't end with submissions or demos. The grand finale will be hosted at the IESA Vision Summit 2026, as Mr. Chandak mentioned, one of the India's most prestigious gatherings of global semiconductor leaders, policymakers, and technology innovators. For the finalists, this means visibility, industry validation, and an opportunity to present solution to the ecosystem that truly matters. So, a hackathon of this depth needs strong industry leadership. We are proud to have NXP Semiconductors, a global leader in secure embedded systems, as the official hackathon sponsor. To share NXP's perspective, expansions, and vision for this hackathon, please welcome our today's guest, Mr. Hitesh Garg, Vice President and India Country Manager, NXP Semiconductors, who is known for development of state-of-art analog mixed signal products, subsystems, and IPs. Sir, over to you.
Very good afternoon, and I would say many thanks to all the participants of this session today. Hope I am audible.
Yes,
Yeah.
sir.
Yes.
Yeah. Yep.
Thank you, Suki, for the nice introduction, and thank you very much, I think, Ashok, for the powerful address. I think you always inspire the whole community. So first of all, I would like to thank IESA for having this unique, first of its kind event, hackathon, as part of the Vision Summit. Of course, I think IESA Vision Summit has been defining the path for this country, that where we have to go, not in the short term, but in the long run. And of course, it's also paving the way that how the steps are, significant steps are taken, consultancy to the government, I think working very closely with the government and also with the industry from all angles to make sure that this country is front leading in semiconductor design, development, manufacturing, and also the complete end-to-end value chain is fully being taken care by IESA. So big thanks for IESA for being such a great partner and creating the vision for the whole of the nation, that how, as we are ramping up, I would say, into this sector. If I think a few years back, it's just a matter of that nobody, if you talk about chips or semiconductor, people used to start asking, okay, what are you talking? But now, if you say semiconductor, I think people see with different kind of respect when we say that we are working in the semiconductor sector. So I think all the efforts of IESA are fully recognized in that direction of making the investors aware, making this, I would say, the country aware, making all the, even the financial community aware that what this sector, why this sector is so important for us. And I think we are all technology people who are there on this. A lot of you are engineers, are budding engineers. So I think this hackathon from our side is an opportunity for you to play with the semiconductor technology. And many of you might have seen the news in last 2 or 3 days. So there are, especially, I think, the big leaders, they were all meeting in Davos. Even our own, I would say, electronics minister, Shri Ashwin Vaishnav, he was also there. So one of so there were multiple news. One of the biggest news item is that what is happening next week, Europe and India. So they are signing a free trade agreement, which is planned to be done on 27. And Madam Ursula von der Leyen, who is the president of European Union, she was saying very highly about India and how this free trade agreement is unlock the possibilities of India as well as Europe to work together so closely. So I think this is an exciting times. At the same time, I think that there are partnerships happening on the technology side. We being a European, I would say, headquartered company, I think we are also part of this great progress in the event which is happening. At the same time, I think there were some questions about AI which were directly asked to Mr. Ashwin Vaishnav, that how are we leading the way, right? And I think those are very interesting and fantastic conversation. Our ministers, right, knowing all these details, explaining to the world that how we are not looking at only at the surface, but how we are deep into this topic of AI at all levels, looking at applications, looking at the technology, looking at the semiconductor, all the 5 layers. So I think he explained it in a very nice way. So I think, just summarizing all this, I think AI is at the center of all the growth engine that we see around us. And so I think, and AI on the cloud, we have seen how much impact it has created. The next, I would say, wave is for AI on the edge. That's where at least NXP we are playing very strong. We have fantastic technologies, and this hackathon is an opportunity for you to come and play with our technologies, which are AI on the edge. I see Malik on the call, so I think Malik is helping us to steer this from NXP side, and big thanks to the IESA organizers. So I keep saying this, right, just to the people. Of course, AI on the edge is going to unlock many opportunities, many efficiencies in the ecosystem. But the real value of AI is when we talk about physical AI, means AI on the edge. A car running at a 200 kilometers per hour does not have time, and we cannot depend on that. That's the signal will be sent from the car running at 200 kilometers per hour to the cloud, and some decision, some processing happens on the cloud, and the signal is sent back so that car can brake, I would say, within few milliseconds. So I think those kind of applications has to happen if it's a real time, if it is bandwidth limited. I think this have to happen on the edge. Similar things, right? How are we making devices more intelligent? And these things can happen, I would say, on the medical side. So maybe if you have an X-ray machine or a CT scanner, so it not only spits out a report, but it also says what are the possible diagnostics, right? This can all happen with the help of edge AI. So I think all these technologies we are bringing to you, and now we have thought of a specific challenge in this regard. Invite all of you to participate in this challenge, and there are exciting prizes also. So with this, I wrap up my conversation, but these are really exciting times, and big thanks to IESA for continue to create this vision and continue to be a great partner in moving the nation forward in the semiconductor race.
Thank you, sir. Thank you, Mr. Garg. So now we come to the heart of hackathon, the problem statements. This hackathon focuses on AI of chip design, that is, AI defect classification for semiconductor wafer die images. To walk us through this, the problem statement, evaluation expectations, and what truly defines a strong solution. I invite Mr. Mallikarjun, Director NXP Semiconductors, who is passionate about leveraging AI and driving digital transformation to revolutionize semiconductor design and development. Sir, over to you.
Thank you. So let me share my screen. Okay, hope all of you can see my screen and hear me.
Absolutely.
All right. First of all, thanks to all the organizers. And we had a very good intro from Mr. Ashok and Mr. Hitesh, who set the stage for the semiconductor industry and what's happening in India and so on. Now, in this portion, in this part, we will talk about what problem are we going to solve and what are some challenges and what are the evaluation criteria and what are the stages that we move on. So the problem statement is, or the title is Edge AI-based defect classification system for semiconductor images. So we'll elaborate what this is. So you would see over there, Edge, AI, and semiconductors. So we're looking at these three things together. So we'll walk through these topics. What's the background and the purpose and objective, and what is the scope? What are you supposed to do? And we will give you some sample images, how the things look like, and what are the deliverables, and evaluation criteria. How are we going to select the best guys from phase 1 to phase 2 to phase 3, and some references. So the background and industry motivation. So some of you, or most of you, particularly if you're in the electronics domain, you would know how the semiconductors are manufactured. So there are millions and millions of chips get manufactured in foundries across Europe, US, and Taiwan, and Singapore, and so on. So each one of these, when you fabricate these chips, they go through multiple processes. They include physical, chemical, optical. You traverse through all these, electrical, and so on. You traverse through all these different stages to make the chip. And it is in a layered approach, which involves hundreds of processing steps and very complex machines and so on. And when you do this, there is a lot of possibility for microscopic defects to get introduced into these chips, which are going to, of course, make the chip fail. And a very tightly controlled process is established to manufacture these devices. In spite of that, you will see the defects in the semiconductors when they are getting manufactured. Of course, you will test them, and then finally you will eliminate all the defects and then ship the good products to customers. So the manufacturing process is a highly complex environment or complex process which involves hundreds of stages, and each one of these stages Each one of these process is susceptible to a lot of environmental conditions and electrical, physical, chemical, optical parameters, and defects can get introduced. And these defects today are captured through the images like optical inspection microscopes, using scanning electron microscopes, atomic force microscopes, and so on. You collect all these images and then probably send it to a central server or a cloud, and then start analyzing them. What the defect is, and what's the type of the defect. First, identifying the defect, and then addressing how do we eliminate this defect, what process corrections need to be taken. So you need to go through some of this manufacturing, semiconductor manufacturing related things to understand the underlying process, just to get an overview of that. And so a lot of these images are taken and sent to a central station for analysis. So today that is the process in most of the foundries. So we are going to address how do we uh, detect or analyze these defects in a easier and faster way. Is that possible? Is what we want to explore using this hackathon. So that's the background. And what is the objective here? We want you to design and build an edge AI powered system that is capable of detecting defects in semiconductor wafers, as I spoke about, and classify them into a predefined categories using EIML methods, and then running in real time on low power edge hardware. So you're going to solve this problem of classifying these captured images and putting them onto edge AI system. So by doing this, you are enabling a faster capture, or instead of taking all the images and going to the cloud and putting them and then analyzing, as soon as the image is captured, you can send it onto an on-device edge device, which is capable of AI analysis, and then detect the system then and there itself, and then work. So this is the end system that we want to build. If all these things go, our experimentation and R&D goes through well. So this is the objective that we want to achieve through this hackathon. Of course, this is quite complex because it involves semiconductor manufacturing, and then AI, and then edge. The three of them are key factors in this entire scope. So what is your scope going to be? And I do want to say this, many of you have already worked on some of the other kind of EIML projects, and most of them involved, and a predefined data set is given to you, and you will run an algorithm or optimize that and solve different problems. I'm sure you have solved multiple of them, like dog breed detection, or handwriting number detection, and face recognition and things like that. Now, most of them have become like high school level problems because the AI is penetrating our lives so fast. Now, in this, the challenge is going to be like the first one is data collection and data set creation. So we want you to go through this manufacturing process, basic understanding, and of course, there's a lot of ChatGPT and other things are available for you to look for some material. Choose or decide a minimum of 6 non-overlapping defect types. So what are the defect types that we are talking about? Shorts in the metal traces, opens, bridges, malformed vias, CMP scratches, cracks, LER, and line edge errors, for example. And there are many more, like about 20 or 30 different classes of these defects. So we are little giving you a freedom to explore, choose at least 6 of these different defects, and start collecting images from the internet or your available sources and create a data set. So this is going to be a big one of the major evaluation criteria in the hackathon. You need to create the data set by collecting the images. We'll show you the sample of the images and then make the data set. So we would suggest a minimum of 500 images to be collected with a good balance of classes. If you take any of those 6 classes, so for each class, have a good balance. You all understand, if you have worked on something on EIML, you know what the balance meaning, class balance meaning. Just to quickly tell you on that. So if you have 100 images, 6 classes, something like 15 for every class is a good class balance. We don't want ideal, but something like that. So do that. And then you also need to collect the clean and other classes. So if we give you some images, you should be able to put them into different defects, or it's a clean or unknown kind of an defect is found, put them into other categories. So there are going to be 8 classes, the minimum you must put. And then about 500 images is what minimum required in our assessment. 1,000 image data set is most preferred, and more than that is always welcome. And don't make it like 100,000. It's difficult and then to handle and all. So that's the first part of the process, data collection and creating a good data set. And these are all typically the black and white images. So no 3-channel or no color images. So keep it to black and white. And second part is build and develop an AML classification model. So your objective is, ideally this should be an object detection exercise, but we will pass that. This is going to be a bit cumbersome given the short amount of time. We will limit this hackathon to classification exercise. So you'll have to just classify if there's a defect in that, what defect category that is. And you could build this classification model using Scratch. So you can train the model from scratch, or you can use transfer learning. Once you do that, third is port the model for edge device deployment. So this model, what you develop, it has to be ported onto edge. So most of your past exercises, you would have just left it on your laptop or left it onto the cloud, and you have huge resources over there, and then the model will run. So this is the second biggest challenge. The middle one, most of you are already aware. The first one is a challenge. Second one is okay. Third one is another biggest challenge, where you need to keep the model size and fitting that into an edge device is very, very crucial. For this, we would want you to use NXP EIQ software, which has all the model porting and estimations and evaluation of fitting into a particular board and so on. We want you to target to NXP devices like i.MX RT series. These are your AI capable, AI processing capable devices. So you could target to these series using NXP IQ software. And please note, we are not expecting you to download it onto the board and then show a demo, because that's going to be too long an exercise. So we will stop at software code porting only in the NXP EIQ. Finally, you document all your findings. So data collection, ML classification, building a classification model using AML, and porting the model onto just software porting only on NXP IQ. So these are going to be your scope. And these are the sample images. So you could see over here, if you do a search, you'll start finding more and more. So this is how your, let me open the pointer. Yeah. So this is how your silicon looks like when these layers are manufactured. So each one layer, you take an electron beam microscope and look at it. So this is how your devices look like. And this is how the metal traces look like. Sometimes what happens is you see here, there is a bridge, a kind of a short, not exact short, but a small connection between the two. So this is a bridge defect, and one more type of bridge defect. And then here you see, this is the clean. And here you could see the CMP is a machine, actually. It's something like polishing machine. Okay, when it does, it creates sometimes scratches because of the process parameters and the machine alignment and things like that. This is another type of defect. And cracks. This is a solder bump and the bump on the connection bump, and you could see a crack over here, and this is another crack. And here some opens. See, you could see this is clean, and this is an open, and this is another open. And then LER, you could see these are all stripe bars, and then here you could see a little bit disturbed bars, and here another example. These are VRs. So you could see very nice VRs over here, and then here the disturbed VRs are malformed VRs. So this is a sample image we have kept, and on the top I put a green box over there. These are all the good images, and then bottom of the defective images of defective systems for the same errors. So we would like you to find your source and then start collecting for these 6, or you can also collect for more different kinds of defects and collect images on that. We give you a little bit of free hand on that. We know how to evaluate each one of you once we reach a particular stage. So these are the sample images. We will share this with you on the landing page. So what are your deliverables going to be? So the deliverables of data set, which we spoke about, you need to create the data set, trained ML model, and then model result. For the first part, model results on you divide train, test, and validation data set and submit as the accuracy, precision, recall, because it's a classification problem. You submit us on the your test data set, and then we will give you a test data set on the trained model. You submit back the results on our test data set. That is number 4 deliverable. Number 5 is NXP ported model result. So when you port this model onto the NXP software, if the porting is successful, it will give you the code binaries. They are text files. So you can measure the number of instructions that get written. So this is going to be one of the deliverable. And then complete code and documentation of methodology. Okay. So there are some notes which you will see when we give you the details, when to submit and how to do and things like that. And this is very important evaluation criteria. What are we going to evaluate you on? So in phase 1, you will do the first 2 steps, that is data collection and AI model development and delivery. And then on this, we are looking at data set quality, size, class balance. So basically, we will evaluate how good your data set is. And second, model accuracy and model size. And then from this, we will shortlist 30 groups. And then we will give you the test data set. On that, again, we ask you to submit the results like accuracy, precision, things like that. So we will again evaluate prediction accuracy, defect class, model can classify, and model size. All of this we will post in the landing page. Once this is done, you will go to phase 3, wherein we will ask you to port the model into Edge AI and then presentation and documentation. This will happen in the grand finale. So here we are looking at successful generation of bit file, size of the generated model stack, and then any patentable concepts, innovation, and so on. One important thing is when you're building the AI model over here, keep in mind the porting for Edge AI. So some of you know why the Edge AI we are stressing here. It will have a small capability to handle. You cannot bring some 1 GB model and put it onto the Edge AI. It won't work. It won't fit. So that's why it is important you keep an idea of that. And we have given evaluation parameters for each one of these phases. So this is going to be the evaluation criteria. And we will give you some documentation and references for porting. For the first phase, you'll be focusing on your data set, model development, and things like that. And then once you pass and get selected for the second and third phases, we will start giving you some more access to the software for porting onto EIQ. So those are going to be the steps and the workflow. All this document will be posted on the landing page. So with that, we come to end of this section. Over to you.
Thank you for the detailed walkthrough. To ensure everyone clearly understands how to participate, what the journey looks like, how to avoid common mistakes, we will now walk you through hackathon phases, timelines, submission formats, mentoring structure, registration and portal flow. I invite Saurabh Uble, I4C Program Manager, to take you through the hackathon flow and live registration walkthrough. Over to you, Saurabh.
Thank you, Suki. And again, I welcome all everybody through this hackathon launch event. And I'll walk you through the hackathon timeline. Uh, we have already taken care of the problem statement. Now we will get to know about hackathon timeline and the registration flow. I'll also walk you through the landing page where all the information is given. So regarding the hackathon timeline, so today, as we said it as a hackathon live, or you can say registrations are open from today. Where
Saurabh, your audio is not clear. Saurabh, your audio is not clear. For others?
Hello?
Yes, same. It's breaking. It was breaking. Still problem, Saurabh.
Okay. Am I audible now? Is it good?
Absolutely great.
Yes, it's good now. Proceed, please. We lost you again.
Saurabh, you may just switch off your video. I think that will give you some more bandwidth.
Yeah,
Okay. Am I audible? Am I audible?
go
Yes.
ahead. Go ahead, please. Yes.
Better now.
Thank you. Thank you. Thank you, sir. Sorry for that glitch. Hope my screen is visible.
Yes, proceed.
Okay. So we were at interactive webinar session. So the webinar sessions will be conducted by the experts from NXP Semiconductors and IESA, where we'll also your doubts related to the problem statement or the solution and answer that. Um, we, as mentioned by Mallikarjun sir, that the problem statement is broken down into the phases, where you have to submit complete the phase one by 8th of February. So deadline to submit your solution for phase one is 8th of February. So all deliverables are mentioned on the landing page, also in the brochure that is available on the landing page. And on and we will take 2 days to evaluate the your solutions. On an 11th February, we'll be announcing the semi-finalist. That is after the phase one. So 30 teams will be selected out of whatever the registrations and idea submission that we receive, and we will announce the selected 30 teams, which will move to phase two. And we will also do a orientation session for phase two participants or the teams selected for the phase two. And we will make you understand what are the deliverables for phase two and expectations. So as mentioned by Mallikarjun sir, we will provide you a data set and the experts will walk you through what is expected you to do in the phase two. So you will get a 6 days of time between to work on the phase two problem statement, and we will announce the phase two uh, results on 18th of February, which are like we'll be selecting 10 teams, which will move on to the grand finale. So on 19th, we will announce the finalists, which are selected for the grand finale. And to help you build your solutions good or to improve your solutions that we will present at the grand finale, we'll be doing a mentoring session for the finalists on 21st of February. And on 25th and 26th, we'll be having the grand finale at IESA Vision Summit, that is in Bangalore. All the details related to travel and accommodation regarding the grand finale will be shared with those 10 finalists within that particular timeline. This was about the timeline. We'll take the questions at the end. So the most exciting part, I'll talk about the prizes. Uh, so the first winner gets 1 lakh rupees of prize. Second, that is first runner-up, gets 60,000 rupees. And the second runner-up, that is the third rank, will get 40,000 rupees. Also, no, it's not about only the cash rewards, but you'll be also getting a stage where all the industry experts will be coming and you will be pitching to them. So that is one thing, something that uh, can be as called as a reward. We'll get to network with the leaders from the semiconductor industry or electronic industry.
Saurabh, I think we lost you
Saurabh,
again.
we are not able to hear you.
Am I audible?
Yes, you are
Am I
back.
audible?
Yes.
Now you are.
Yeah. So, yeah. Also, if you are too good with your solution and with your presentations or with your knowledge, you can be also presented with the possibility of career opportunities. That is, you may get land up a internship opportunity or hiring opportunity.
So Sharab, is the Q&A section open? Can somebody ask the questions in Q&A?
Yes, Q&A session is open, but
So
we
we
have
will
to
now
walk them
move
through
on.
the.
Okay, please continue then.
Okay, then let's continue. We will now move on to a focused live Q&A session. Our panel from IESA, NXP Semiconductors, and I4C will address your key questions related to eligibility, team formation, problem selections, evaluation, and submissions. Please post your questions in the chat.
Hello.
So what is the track 2 problems? What is track 2 problems? That
We
was the
didn't
question
understand.
asked.
We didn't understand the question.
Yeah.
Track 2. What is
Okay,
track
maybe
2?
phase 2. Yeah. Yeah. Maybe they're asking phase 2, but no, let them. Phase 2 is like what Malika sir has already told. You will be provided with a data set. Once you are qualified for the 30 teams, we'll also have a separate session for that 30 teams for a phase 2. Right, sir?
Yes.
So I don't see any questions. Yeah.
Maybe they are still preparing the questions.
Does the
Uh,
data set need to be same as the sample images? Malika sir.
Yeah, we already told the sample images are for your reference. And then as long as these defects that you choose fall into wafer and dice manufacturing, we will accept that. You don't need to stick to the images that we shown or the defect types we have shown. There may be at least 20 different other defect types. If you feel comfortable with other defects, go ahead and choose. We know how to evaluate. You have the free hand there.
Should we submit any PPT?
Sorry?
If you come into last 10, yes, in that case, definitely we need to. Or I think Sharab, you will be able to answer this.
Yeah, sir. Can I'll walk first through the registration process and then we'll take the questions. So I hope that's okay.
Please
Yeah.
continue.
Yeah. Thank you. So now we will get to know about the registration process. I hope my screen is visible. So this is our landing page where you have to go and register. All the information is also displayed on the landing page. Here is the registration button. You have to click here and go to the registration form. So once you register, you'll land on the hackathon portal where you have registered. have to click on the registration, fill the basic details. Once you register, you have to fill the details, and you will get a two-step authentication. You will receive a code on your email ID. To put that, verify yourself, and then it will ask you, you have to register as a team, then as a team captain, as a student, as this hackathon is only for the students. You have to fill all the details that are asked here. These are quite important for us to verify you. Fill the details, click on the consent box, and save and complete. Once you save, you will get to your own hackathon dashboard where you will see submit new idea button. Then just click on submit new idea, where that you have to now complete your team registrations. So you have to give your team name, team tagline, add your members, whatever details that have been asked over the portal, and you can add up to 2 or 3 members. So total team of 4 members. Once you have done, you have added, click on next, and then you will go to the idea submission page where you have to choose the problem statement that is displayed, upload the file, upload the link if you have a GitHub link, and then choose, click the buttons, give your consent, and then submit. Once you have submitted the idea, you can check or manage the idea submitted on the manage submitted idea, where you can delete or edit your idea. So this is quite a simple process of the registration and idea submission.
Shahrukh, quickly go to the chat section. There are a lot of questions asked. Okay, just read it out and
Okay.
let's close it.
Okay. So now we will go to the live Q&A.
Just go to the chat session and read through the questions.
So we have page 1 should be submitted a PPT about solution or should be submit deployed prototype. Whatever you work, there is a template given. In that template, you have to put your solution, your all the data set or all the images that you collect in a zip file as per the instructions given on the landing page. So here's the file. What should be included in the file that is already mentioned? Uh, like you have to give your results in the file, a file of a data set. Yes, the hackathon is completely software. The link will be shared. If you go and search DeepTech Hackathon, you will get the link. Only one problem statement is presented, so you have to respond only the one given problem statement. Does data set needs to be same as of the sample images? Can be.
That we already addressed.
Yes, yeah. Okay, so I see no more questions.
I do see some
Saurabh?
questions scrolling there.
Hello.
Yeah.
Yeah, just
Page 1 should be
sir, just
submitted to.
check in the chat.
Yeah, I'm checking. How we will be able to submit our data set. Submit the data set. You have to give your data set in the GitHub file that you will share in the PPT and the portal also.
How many problem statements can be submitted? Problem statement is only one that we have given.
One. Yes, yes, yes. Problem statement is only one.
Will participants get the certificate even if they don't pass?
Every participant will receive a certificate, digital format.
The portal was not opening to register. It is open from morning. I've seen many people calling and telling me we have already registered.
Yeah,
Check it out
it
once
is
again.
open. Check a network at your site. It is open.
Phase 1, should we submit the PPT about our solution?
Yes, yes, yes. Our solution, as in the solution related to the problem statement given, and the deliverables for the phase one.
Yes, all the phases are online, first and second. Only third phase is offline. That is on Vision Submit event day, 25th and 26th. You guys, if you are in the top 10 team, you will be traveling to Bangalore. It will be supported by IESA. Sharab, the site cannot be reached. They have put some image. Check it out, the registration page.
We'll check it. We'll check it. Yeah. In some time it will get. There's some server issue. It will get.
Okay, let me take one question. Someone said, sir, at submission, do we need to submit project as a software, like a software of this project? Okay, see, we are looking at three aspects, three parts to be submitted. One, a PPT for which the template is provided. Put all your data here. What are your thoughts? What is your methodology? How did you approach the problem? How do you see this entire thing? So for that, we have provided a template that you must submit for phase one. In the same, during the same submission, you also submit your data set in a zip file through GitHub link. And for that, we have given a format on the landing page, how your directory structure, all that should be there. And third, you must document your results. What is the precision? What is the accuracy? What is the thing? That also probably go into the same PPT. You're not going to submit your project, software kind of a project. So you will submit, of course, your code, and of course, you will submit your data set and the results. So all this will be very clearly described in the landing page document. Is there any recommended public resource for data sets? Okay, this is a good question. You must look at, there are small bits and pieces data sets are available on the internet. You need to go through them, you need to understand them, but mostly your search is going to be through research papers. You will get 1, 2, 3 images. You need to start collecting them and start building the data set. As we said, this is the biggest challenge for you in this hackathon.
Is the PPT format given in the landing page, Sharab? Sharab is there?
Yes, yes. The PPT template is given in the landing page.
Okay.
PPT template in the resource links, everything is given.
See, someone responded, Pratham Lagad. Code, data set, results, and PPT for phase one. Got it. That's correct.
Yes, yes. That's correct. Yeah. Okay.
Someone said, sorry, can we take wafer map images instead of die set image? See, there is one wafer map data set that's available. It shows defects in different wafer. That is an about some 68,000 images that someone generated and kept it on the internet. That is not going to work for this hackathon. That's not the problem that we are trying to solve. We're not trying to solve where are all the defects concentrated on a wafer. That is the data set. So that data set would not be useful here. Abhishek, yeah.
So, Sharab, just give reachability, whoever, whatever doubts they want to ask, any mail ID, any how to reach you and things
Yes,
like
yes,
that
yes,
in
yes.
the contact page?
Everything. Yes, yes.
Yeah.
Everything is there in the landing page. Email ID is there. Contact number is there. WhatsApp group link also is there where you can directly post your message.
Saurabh, many are complaining it is coming as this site is not able to reach. Think you will have to.
Maybe server
um,
issue, something like that. Kind of.
okay. Someone asked the question, sir, what is the expected size scale of the images that we should be working for data set like 100 nanometer, 200 nanometer scale? Okay, you are mixing two things over there. Okay, first of all, the image size, you can choose whatever comfortable for you based on what kind of images that you get. And of course, you can train your model based on that. It could be a lower resolution, higher resolution image. You decide the size because we're not giving you the data set. We are giving that free hand to you. I didn't understand what is like 100 nanometer, 200 nanometer scale. Shivam, please clarify what you meant by 100 nanometer scale. I don't see any new
WhatsApp link
question.
is not working. What is that WhatsApp link?
Okay. Shall we move on to the next section? We will take the
Yeah.
questions. Okay. Yeah.
Yes, yes, yes. I think we
Yes. Yes.
One,
time to.
one last question. What should be the minimum number of images? We have already answered that. So as an AML engineer, you know some good number of images are required. We would prefer about 500 images. 1,000 is even more desired. Okay, we will take more questions in a different channel. Thank you.
Sure.
So, as we approach the conclusion of today's session, it is my privilege to invite the brain behind I4C and world's largest open innovation hackathon model, that Smart India Hackathon. Ex-HP director, author, educationist, who is known for his book on theory of computation and now working on greater mission of increase in the employability of India, Dr. Vivek Kulkarni, CEO I4C, to deliver the vote of thanks. Sir, over to you.
Thank you so much. I hope my voice is audible.
Yes, sir, it's clear. Please proceed.
Great. Hey, so first of all, thanks to IESA that this is one of the kind hackathons aptly at the right moment when the whole world, I think we are talking about India semiconductor mission, right? So thanks for this step, and I'm sure that this step will be, of course, a miniature step, but towards achieving that semiconductor mission. The primary goal and why we should be doing these more frequently, and of course, thanks to NXP coming forth, sponsoring this event, we have the problem statement, at least one of it, which is well explained in today's call. Still, there will be doubts, and students are requested because this is the one of its kind hackathon that we are doing. Make use of it. At India level, what is more important at this stage is to build the talent in chip design. And we really urge more and more people to actually participate as participants, as even professionals who would actually can mentor you. Get your bonds connected through the Vision Summit. These are all leaders and stalwarts practicing chip design and embedded systems would be around. And I think students should actually make use of this. Winning, as I always say, even for Smart India Hackathon that we did recently, I think Smart India Hackathon or any hackathon for that matter is primarily should be used as a learning tool than anything else. Uh, Take that as an opportunity to learn new things, try to prove things that if you could, I mean, attempt is far more important than winning the game. So everybody who would attempt would be the winner, in my opinion. So thanks to all of you providing this platform. I understand there are some glitches out there right now. There are many questions, but there is a WhatsApp group being created for all this. I want to see more and more messages there. Maybe I'll close my small speech at this stage. Let's make India proud. Let's make and build better talent in this space as well. Thank you so much. Over to you.
Thank you. Thank you, Vivek. Can I just add one
Thank
line
you.
here?
Yeah, please, sir.
Go ahead.
You said it. You said it very, very nicely. Use this as a learning platform and enhance your knowledge, guys. Your focus is not just winning this hackathon by saying some data set and so on. You will learn a lot of electronics related stuff, which is going to be a driving, which is almost already a driving force in India. You will see a lot of opportunities. So I think it would be a very well time spent on this problem because you will learn a lot of things over there. Sorry, Vivek. Thanks. Yeah.
No, thank you so much, Anil.
Thank
So
you.
thank you so much. I think we can proceed further. We can close it, Sharab.
Yes,
Thank you,
yes.
Dr.
So we'll
Vivek
continue.
Kulkarni. Yes. Thank you, Dr. Vivek Kulkarni. To everyone who has joined us today, students, faculty members, mentors, professionals, and partners, thank you for being part of this launch. Registrations are now open. The hackathon journey has officially begun. Updates will